Atwood machine. See here, you know about the well. How you can take out the water from the well? It is for your understanding. Just I am taking. This is one well. Uh, Here it is. One axle is there. One person it is pulling the rope like this, and another rope it is going like this. This is bucket. Isn't it? The water it is taking out like this. Isn't it? What is the tensional force? One person it is pulling this rope from here. What is the tensional force is acting in the rope? What is the acceleration of the bucket and what is the acceleration of this side? We have to calculate. See, in this situation, I am taking this diagram is like this. One beam, frictionless pulley I am taking. Frictionless pulley. One side it is mass m1, one side it is mass m1, and another one it is I am taking mass m2. This is mass m2. Just both are placed now initially on the horizontal surface, on a horizontal surface. Now suddenly I remove that one. When I remove, here mass of the first object is greater than second object. When I remove my hand, mass of the object is greater than mass of the second object means how this diagram will becomes, how the diagram will becomes means it is mass of the first object is moving downward direction and mass of the second object will be goes upward direction. Mass of the second object is going up means it is accelerating downward direction and this is the accelerating upward direction. It is accelerating downward and it is accelerating upward. Now take the free body diagram of the first m1 mass. I am writing it is m1 mass. I am writing, see here, m1 mass. It is tensional force. What is the tensional force means? A force which is acting always away from the object. A force which is acting always away from the object. For your understanding, I am writing here. This is mass. The tensional force. One string is connected like this. Now tensional force is away from the object. If you take the object like this, one string is now connected like this. It is away from the object. Tensional force is always away from the object. And one more time I am taking, if the string is connected like this, it is away from the object. If you take one more, upward direction if I take it is away from the object. Tensional force is always away from the object, isn't it? And also you can take here, string is nothing but a thread. String we can call it is the thread. See here, in my shirt, when I am pulling, it is nothing but a, when I apply the force like this, you can observe the stiffness. You can observe the stiffness. When I remove the applied force, it is coming into the original position. Means here a force try to keep an object into the original position. That is, we can call it is the tensional force in the string. A force try to keep an object into its original position. That we can call it is the tensional force. Okay. From this one, these are the diagrams. Just I am drawing free body diagram of the first object. M1 I am writing. Now in this situation, string is connected like this. See, tensional force is acting upward direction. Tensional force is acting upward direction according to the tensional force. I told you once again, I am want to tell here, tensional force is always away from the object. Tensional force is always away from the object like this. See here, tensional force here, the object is here, tensional force is upward direction. Okay. Weight of the object is acting downward direction. Weight of the object. Weight is always acting downward direction towards the center of earth. So that is downward. It is moving downward direction or upward direction. It is moving downward direction. If it is moving downward direction, so acceleration of the block is downward. I am writing acceleration of the block is downward direction. Now resultant force is equal to downward force minus upward force. Resultant force is equal to downward force minus upward force. Why we have to write downward force minus upward force? Because the object is moving downward direction. When object is moving downward direction means this downward force is greater than the upward force. Downward force is greater than the upward force. So the resultant force is equal to greater force minus lesser force. Greater force minus lesser force. In this situation, downward force is the greater force and upward force is the lesser force. So resultant force is equal to downward force minus upward force. What is according to the Newton's second law? F is equal to ma. So this is m1a is equal to m1g minus t. m1g minus t. Now t, if I take this side, t equal to m1g plus m1. This is will become plus, and if I take this side, this is m1a, isn't it? It is equation number 1. T equal. Next, I am taking it is the second one, m2. I am taking it is the second one. In this second one, free body diagram of the second one. String is connected upward like this. This is mass m2. Tensional force is acting upward. Tensional force is acting upward. Weight of the object is m2g. It is acting downward direction. What is acceleration? Acceleration is upward direction. See, acceleration it is upward. Acceleration is upward means what is the resultant force? According to this diagram, we have to write it is resultant force. Resultant force is equal to upward force minus downward force. Upward force minus downward force. Why I have written it is upward force minus downward force means now the object is going upward direction. When object is going upward direction means upward force is greater than the downward force. Upward force is greater than the downward force. So that's why I am writing here. I will tell you one example here. See, one person it is standing like this. Here, one more person it is pulling towards himself. And one more person it is pulling along this direction, isn't it? In middle person, this person it is pulling along this direction, this person it is pulling along this direction. For example, this person it is acting 10 Newton's force, he is pulling with the 7 Newton force. 7 Newton force. Now, this person will move towards the right side or towards the left side. The person will move towards right side because it is the greater force and this is the lesser force. So greater force, what is the resultant force means? 10 minus 7. 10 minus greater force minus lesser force. Okay, fine. Resultant force. According to the Newton's second law, m2a is equal to t minus m2g, isn't it? Now this is equation 2. Substitute equation 1 in equation 2. Substitute equation 1 in equation 2. If you substitute like this, first I am writing equation 1 I am writing in this one. So m2a is equal to t is nothing but t equal to this one m1g minus m1a, here t minus m2g, so minus m2g. Just I substituted equation 2 in equation 1. Sorry, equation 1 in equation 2 means this is the equation here. This t is equal to I have written. In this one, g term, a terms I am taking one side. m2a plus minus m1a is there. If you take this side, m1a, that is equal to m1g minus m2g. Now what you can take common in this one? A. So m1 plus m2 is equal to, if you take the common g, m1 minus m2g. Then acceleration of the block, A is equal to m1 minus m2 divided by m1 plus m2 into g. This is acceleration of the blocks. Acceleration of the blocks, it is nothing but a m1 minus m2 divided by m1 plus m2 into g. What is the tensional force now? We want to calculate tensional force. This is equation number 3. Substitute equation 3. Substitute equation 3 either in equation 1 or equation 2. Now I am writing it in equation 1. So T is equal to m1g minus m1 A equal to this one. This one I am writing m1 minus m2 divided by m1 plus m2 into g. Now what is LCM here? LCM is T is equal to m1g minus, first time this is m1, so m1 plus m2 minus m1 square g plus m1 m2 g. Again you have to multiply this one. T is equal to m1 into m1 square g, and m1 into m2, that is plus m1 m2 g minus m1 square g plus m1 m2 g whole divided by m1 plus m2. In this one, what we can get cancelled here? These two get cancelled, isn't it? And also m1 m2g, m1 m2g, that is 2 m1 m2g. So 2 m1 m2 divided by m1 plus m2 into g. So total is nothing but a tensional force in the string. T is equal to 2 m1 m2 divided by m1 plus m2 into g. Further, see here we taken pulleys like this. It is frictionless pulley. This is m1 we consider, this is m2. Now what here tensional force is T, here tensional force is T. What is the tensional force is T dash here? Here T dash is equal to how much? We calculated this T is equal to this one, this T is equal to this one. What is the tensional force acting here? Here total tensional force is acting on this body. Total tensional force is acting on the body. So T dash is equal to, you can write T plus T, that equal to 2T. So multiply here. T dash is equal to 2 into 2 m1 m2 divided by m1 plus m2 into g. So tensional force in the string, it is nothing but this one. Tensional force on the pulley is nothing but this is the equation, and acceleration of the object is nothing but this is the equation. About this is the Atwood machine. If we take the Atwood machine is like this, isn't it? This is frictionless pulley we are arranging here, and this is one object, isn't it? Now the light, it is the tensionless string, it is frictionless pulley, and the string is passing over the frictionless pulley, and we are writing it is mass m1, this is mass m2. Mass m1 it is greater than, according to this one I am writing here, mass m1 is greater than m2. So this mass of the block is greater than mass m2. So the when object is accelerating downward direction, when object is accelerating downward direction, this mass, the second object is accelerating towards the pulley. It is accelerating towards the pulley. At that moment, what is the tensional force? What is the acceleration? We have to write it. What is the tensional force and acceleration? Okay. Again, we have to consider the free body diagram. Free body diagram of the M1. This is M1. String is connected like this. We know very well, tensional force is always away from the object. Tensional force is always away from the object. Weight of the object is acting downward direction. Weight of the object is accelerating downward. So weight is acting towards the center downward, and it is accelerating downward direction. Accelerating downward direction. What is the resultant force? According to this free body diagram, resultant force is equal to downward force minus upward force, because the object is accelerating downward. Object is moving downward direction. So downward force is greater than the upward force, m1g minus t. According to the Newton's second law, resultant force is equal to me, that I am writing is m1g minus t. Then t equal to, these two we can exchange it, m1g minus m1a. That is equation number 1. Okay, go for the next one. This is m2, isn't it? It is lying on a horizontal surface. The tensional force is always away from the object, isn't it? Is there any opposing force here? No opposing force. Only one force is acting along this direction. There is no opposing force. See here, if you coming to here, one object m1g is acting downward direction. Opposing force is the tensional force. At that time you have written it is the Resultant force is equal to of greater force minus lesser force. Here only one kind of the force is acting. So that's why this tensional force you can write as a F. Tensional force you can write as a F. So T is equal to M to A. It is accelerating. Now substitute equation 2 in equation 1. Substitute equation 2 in equation 1. In 1. If you substitute T equal to M to A, T equal to M to A equal to M1G minus M1A. Now this M1A I am taking this side. M1A plus M2A equal to M1G. What is the acceleration here? M1 if you take the A, if you take the common, then A equal to, you can write M1G whole divided by M1 plus M2. Acceleration of the blocks. Acceleration of the block. And if you substitute this equation, substitute equation 3 in equation 2, you can get tensional force. T is equal to M2 A. A means this one. M2 M1 G divided by M1 plus M2. This is the tensional force. About this diagram, acceleration. About this diagram, what is acceleration and tensional force, isn't it?